Alright, this is our video for Intro to Logs. Today we're going to simplify logs, go over the 4 basic log rules, and we're going to take a look at expanding and condensing. If you need a longer look at anything, please don't hesitate to pause, take a look at it, rewind, listen to it again, whatever you need to do to understand. So first of all, what is a log? A logarithmic operation is the opposite of an exponential operation. So just like the square root is opposite of a square, how it undoes a square, a log undoes an exponential operation. Log base a is the opposite of a to the x. All right. So if I did log base a of a to the x, I would end up with just x. They undo each other. If I had a to the power log base a x, they're opposites, they would cancel out, I would just end up with x. It answers the question, a to the power what will give me x? So for example, log base 3 of 9 asks the question, 3 to the power what will give me 9? Now 3 to the power 2 will give me 9 because we know 3 squared is 9. So that means that log base 3 of 9 is equal to 2. When you see log with no base at all, this base is automatically 10. Just like if you see a square root without, if you see a radical with no number above the radical, you assume it's a square root. You assume there's an invisible 2 there. When you see log with no base, you assume that there's an invisible 10 there. So log x is equal to log base 10x. When you see ln, it literally means natural log and is equivalent to log base e. So ln x is the same thing as saying log base e x. E is what's known as the natural number. It's a constant, just like pi. It's approximately 2.718, blah, 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 keeps going. But it's just a number. So E will always be the same number. Let's look at the 4 basic log rules. We have log a times b equals log a plus log b. So just like when you multiply exponents with the same base, you add the exponents. Since log is the exact opposite of it, the rule is kind of the same. If you're taking the log of 2 numbers that are multiplying each other, you can take the log of each one separately and add them together. It'll be the same thing. So if multiplying makes you add, then guess what subtracting does? Subtracting makes you divide. So log a divided by b is the same thing as log a minus log b. Log a to the power b is equal to b log a. I like to call this one logga blogga. You'll notice that all we're doing is taking the b at the top and moving it down in front of log a. So whatever is in the exponent, you can bring it down and multiply. And this is one of the main reasons we actually use log, is when we have an unknown in the exponent, we use logs to take that exponent down so we can then solve for it. So if I was in a situation where I had a to the b in an equation and I needed to solve for b, I would use logs, if I can't get the same base, to bring that b down. This is known as the change of base formula. If you ever need to change the base, all you have to do is take log a and bring that to the bottom, and you take x and bring that to the top, and that allows you to change the base to whatever you need to. All right, so here are your 4 basic log rules. I would pause right here, either write them down, take a screenshot, take a picture, because you're going to be using these rules over and over again. So let's take a look at expanding log expressions. We want to expand the logarithm log base 3 of 3x squared divided by n. Here are 4 basic log rules. when expanding the log of a fraction, whatever is on top will be positive, and whatever is in the denominator will be negative. This basically utilizes the first two log rules, where multiplying makes you add and dividing makes you subtract. Now, if you're dividing by multiple things, you would just subtract multiple things. Everything in the denominator will become negative. So this gives us log base 3 of 3, log base 3x squared minus log base 3n. Applying rules to simplifying logs, if I'm trying to find log base 3 of 3, I'm answering the question 3 to the what would give me 3? Well, 3 to the 1 would give me 3. So log base 3 of 3 is 1. Log base 3 of x squared can be further simplified using log-a-blogger. You'll notice that I take the 2 that's up there and just put it in front right there. So that gives me 1 plus 2 log base 3x minus log base 3n. Now this can also be condensed by going in the opposite direction. Whatever is positive will go in the numerator, and whatever is negative will go in the denominator. So this could become this. The 1 could be expressed as log base 3 of 3, since both of these are log base 3. The 2 can go in the exponent of the x. We didn't do anything with the negative log base 3n. And then this would then turn into this, where the positive log expressions would end up in the numerator, the 3 and the x squared, and the negative would end up in the denominator, so that's divided by n. And what you'll notice is in order to do this, the bases would all have to be the same. That's why we changed the 1 into log base 3 of 3, so that we have log base 3 of everything. And so that's it. If you have any questions, please let me know.